In this lecture, we'll be considering the idea of slope fields. And a slope field, in a sense, is simply a graphical representation of the slopes of possible solution equations at all possible points. So what we have here is an equation dy dx equals y, and we can think of that as simply meaning that the slope at any point for some curve is equal to the y value. And I've used a dot graphical representation just to make things make more sense, but I have an x and a y graph. Everything is counting by ones, 2 and 3, positive 1, positive 2, positive 3. And what I'm going to do is I'm going to plot linear representations of all of the slopes at every point, and I'm just going to do this for the whole grid. So for example, at the coordinate -3, 3, the slope is equal to the y value, so that would be a slope of 3, and 3 is relatively steep. And this would be true at every y value of 3. The slope is going to be kind of steep. And so what I'm doing, in a sense, is sketching in all of the tangent lines to a possible solution curve at that point. Now, at the y value -3, 2, again, the slope is equal to the y value, so that's going to have a slope of 2. It's going to be less steep than the ones at 3, and I'm just going to do the best I can to show that. At -3, 1, the slope is going to be 1, and again, I'm just going to do my best to show that it's not as steep as the things above it. At 0, the slope will be 0, so they'll all be horizontal lines at each of those coordinates, because again, in this problem, the slope is equal to the y value. At -3, -1, the slope will be -1. So again, I'll show that, just sketching a rough approximation of what the tangent line would look like. At -3, -2, the slope would be -2, so it's going down, but a little steeper. And at -3, -3, again, at every point here, the slope is equivalent to the y value. So I'm just sketching in visual representations of that. So this is my slope field for all of these points. I've sketched them in. And now in part A, I'll answer in red. The question is, find the solution going through 1, 1. So first let me find the coordinate of the point 1, 1. That's right here. And I know that at that point, the tangent line will have a slope of 1. And there's some curve then that's going to follow the path that's outlined by all of these specific slope fields. Now the key here is just to sketch it in as best you can without ever crossing any of the other points. Use them as kind of bumpers or roadblocks, but never cross them. Only have them touch the one point that you know. So what I'm going to do is I can see that as from my point at 1, 1, this thing is, as I move to the left, is going to get more and more horizontal. So I'm just going to sketch something in that's getting more and more horizontal, using my other slope field lines as guides, but being careful never to touch them. And as I move to the right, my curve should be getting steeper and steeper, and so I'm going to illustrate that, but again, being careful not to touch any of the other lines. I just happen to know its tangent at 1, 1. So that would be my solution curve for A. Now for B, I'll do that in blue, -2, 0. And so first I'll locate that point. So here's -2, 0, where the slope is 0. And now I'll sketch in a solution curve. And so my solution curve is going to look something like this. And someone might argue that it's staying tangent there, and it very well could as I move to the left, but I'm just being as cautious as I can. So there's my two solutions and my slope field. So let me set up, I'll do a second example. I'll do dy dx equals x plus y. So in this final example, example 4, we're told that dy dx, or the slope, is equal to the x coordinate plus the y coordinate at every point in our grid. And in our chart, we've got all points from -3 to 3 for x and y values, so we'll just use those. And so I'm just going to go step by step here. At -3, 3, x plus y is 0. So at that coordinate, -3, 3, I should have a horizontal line. And that's going to be true at -2, 2, and at -1, 1, and 0, 0, and 1, -1, and 2, -2, and 3, -3. So I've got my slope field for all the points that are opposites. Now I'll just go and I'll do -3, 2, which would be -1. So the slope there would be -1. So that's going to be decreasing and going down. At -3, 1, the slope should be -2, so a little steeper. At -3, 0, it should be -3, so a little steeper. -3, -1. And again, I'm just doing my best all the way down to show that it's getting steeper. At -3, -3, the slope is -6, which is pretty steep. At the point -2, 3, the slope is +1. Maybe something like that. And then again, just working my way down, adding the coordinates together, because that's how the slope is defined here. At -2, 1, that would be -1. At -2, 0, it would be -2. And again, I'm just approximating steepness. I was going to get a ruler out and measure it. At -1, 3, the slope should be 2. And then it'll be +1. And then 0. And then at -1, 0, the slope is -1. And then -2, and -3, and -4. I'm going to do this for every point on the grid. And so there I've sketched everything in, all my different slopes at the different points. And now the last part is simply to find the solution. So I'll do the first solution at the point 1, 1 in red. So 1, 1 is here. And let's put my point tangent above it. It can go in either place. It doesn't really matter. And now I'm just going to sketch the curve as it moves to the right, following the rest of the slope field, making a path, and sketch the curve going to the left, again using the rest of the slope field to make a path. For the second part, part B, I'll do in blue, and at the point -2, -1, I've got a tangent point there. As I move to the left, again I'll just be following the rest of the slope field as it follows the path, and the rest of the slope field as it follows the path. Again, the key principle as you're just sketching in your solution curve is emphasize your point of tangency, and then move following the path of the indicated slopes without touching any of the other ones. So I've sketched my slope field, and I've sketched in my solution curves.